Hi guys, welcome back to my YouTube channel Code Ground, the battleground of coding. So today we are going to solve the daily coding challenge of October 8, 2025. That is successful pairs of spells and potions. Okay, uh, so let's see what the question is. You are given two positive integer arrays, spells and potions of length n and m respectively, where spells of I represents the strength of the ith spell and potions of j represents the strength of the jth potion. Okay, so we are basically given two integer arrays, where the spells and potions are the names of those arrays, where spells of I represents the strength of the ith spell, and the portion of j represents the strength of the jth portion. Okay, you are also given an integer success. We are given a single integer. A spell and potion pair is considered successful if the product of their strengths is at least success. Okay, so let's see what that is. So we are having spells and potions here in the first example. So let's take a pair. So first, let me explain what this is. So we are having two integer arrays, right? So taking one integer from the first array, that is spells, and taking second integer from potions, and if we multiply them, uh, their product should be greater than or equal to success. If that product is greater than or equal to success, that pair is considered successful. So let's see with an example. Uh, let's take 5 from spells and 1 from potions. Then let's multiply them. So what is their multiplication? 5 into 1, that is 5. So the product is 5 and the integer success is 7. So 5 is less than 7. So 5 and 1 is not considered to be a successful pair. So let's take another pair, 5, and from portions, let's take 2. What's their product? 5 into 2, that is 10. And the product is 10 and the success is 7. So 10 is greater than 7. So yeah, so 5 and 2 is considered to be a successful pair. Now let's see. The last line. Return an integer array pairs of length n, where pairs of I is the number of portions that will form a successful pair with the ith spell. Okay, so our integer array, which should be returned, that is pairs, should be the same length as the spells. And what should be in each index? In each index, there should be the number of portions that will be forming a successful pair with the ith spell. So pairs of I is the number of portions that will be forming a successful pair with spells of I. So let's see. With 5, the integers 2, 3, 4, and 5 can form successful pairs because 5 into 2, 5 into 3, 5 into 4, and 5 into 5. All these four multiplications will result in a number that is greater than 7. So for spells of 0, the answer is pairs of 0, that is 4. And in the same way for 1, 1 into 1, 1 into 2, 1 into 3, 1 into 4, 1 into 5. None of them will result in a number greater than 7. And for 3, 3 into 2, 3 into 3, 3 into 4, 3 into 5, 3 into 1. From all these, only 3 into 3, 3 into 4, 3 into 5 result in a uh, will result in multiplications greater than 7. So yeah, this is the overall explanation of the question. Now let's think how to solve it. So there are basically many ways of solving it. Let's first discuss a simple brute force approach. So yeah, let's code it while discussing. Uh, so let's see. Int m equals to spells dot size and int n equals to portions dot size. Okay. Uh, Now we can have a, a vector of int, which will be the pace, as said in the question. Uh, Now we can have two for loops. 1 second, the vector spelling is wrong. Yeah. Now we'll have two for loops. One is int I equals to 0, the out of a loop, I less than m, I plus plus, which will run for the spells because it is running m times and m is the length of spells array. So it'll run for spells. Uh, we'll have inner for loop, which is for int j equals to 0, j less than n, and j plus plus. The inner for loop is for every portion. It runs n times. Now we want product. The product should be not of the type int because long success. So as we are about to compare product with success, then that is the reason we should have the product also as long. So whenever we have a confusion what kind of data type we should use, simply compare the seal values. For example, spells of I, the highest value of spells of I is 10 power 5. Portions of I, the highest value of 10 power 5 is the highest value of portions of I is 10 power 5. So resulting in a multiplication, 10 power 5 into 10 power 5 will be 10 power 10, which is an overflow for the data type integer. So we should use long. This is again one of the clue. So long product equals to uh, spells of I into portions of j. Great. Here we can have count equals to 0 because the count will tell us how many number of portions are ready to make a successful pair with the spells of I. Now, if product is greater than or equal to success, uh, then we should increase count. Count plus equals to 1. Great. Now we can push the count. Pairs dot push back count. Great. And now we are returning pairs. Great. Now let's run and see if the base cases pass. What is this? Integer overflow. Again, we should type cast it here. Great. Yeah, now we'll not have an overflow. Yeah, so we passed the test cases, the basic sample test cases. Let's submit and see what happens. See, we'll get a time limit exceeded error. Yeah, we've got it. Time limit exceeded. And let's analyze. Why did we get this time limit exceeded? So basically, the length of the spells array is also 10 power 5 in the worst case, and the length of the portions array is also 10 power 5 in the worst case, resulting in a 10 power 10. That is n square time complexity for this activity, for the highlighted activity. So we need to reduce the time complexity. Maybe we can make it n log n. So n log n will result in a better time taken to solve this problem, run this problem. Yeah. So what should we do to make the inner for loop log n? Simply, we can use binary search, right? That is one of the uh, great approaches we can use. So let's remove this count because we don't need this count. What we need is we need a left variable, which is 0, and right, which is portions dot length minus 1, that is n minus 1. Great. Now, instead of this for loop, we can use a while loop. While left is less than or equal to right, what should we do? We should have a mid. Int mid equals to L plus H. It is not L plus, it is left plus right. Left plus right by 2. And what will be the product? Long product equals to typecast it of cells of I into portions of mid. Great. Uh, Now if product is greater than or equal to success, if one element is matching, then in binary search, the first point is the portions array should be sorted. Sort of portions dot begin comma portions dot end. Okay, yeah. So if one element satisfies the condition in a sorted binary search approach in a binary search array, then all the elements to the right of it will satisfy the condition. So we need to move to left to see whether more elements satisfy our condition. So we need to move to left. Uh, so before that, we need to have an index to see how many satisfy the condition. Let's take it as portions dot length. Before taking it, let's make it n. Yeah. Uh, why is this index as n? I'll explain it to you. Great. If product is greater than or equal to success, then we need to move to the left. What does moving to the left mean? We should make index as mid, and then uh, right equals to mid minus one. We have moved to the left. Great. And else we should move to the right. Left equals to mid plus one. Great. And what do we need to push back? We need to push back the count. And what is count? Int count equals to C. Uh, Basically, the count will be n minus index, right? And why is it n minus index? Because until a certain point, if the condition is satisfied, if the condition of being a successful pair is satisfied, after that all the elements will be satisfied till the end of the array. Uh, as we can see here, this is a sorted array, and for 5, if 2 is satisfied, after 2, everything will be satisfied. 2, 3, 4, 5, and everything. And for 3, if 3 is satisfied, after 3, everything will be satisfied. 3, 4, 5. So, we need to check for the first element that is satisfying our condition. The first element that is satisfying our condition will be our index. And why did we take index as n? Because if no element is satisfying our condition, then the index will be n only, and the count will be n minus n, that will be 0. And this is the small logic I have used here. And then we are adding it to our pairs array, and we are returning the pairs. Let's see. Count equals to n minus index. What does this mean? Uh, I should be moving this index out of the loop because it is unrecognizable after the loop. Yeah, great. Now let's submit. Great. We have passed all the test cases. Yeah. So this is how we should be solving this problem using a binary search approach. Also with brute force it can be solved, but we'll get a time limit exceeded error for the provided constraints. Yeah. So this is all for today. Hope you liked the video. Please make sure to like, comment, share, and subscribe to my channel for more such content, for more such interview related problems. Yeah. So this is all for today. Uh, Thank you. Bye.